Good morning. I am Dr. Sugita. So today we are going to see the example commercial applications of ad hoc networking. Ad hoc wireless networks, due to their quick and economically less demanding deployment, find applications in several areas. Some important applications are military applications, collaborative and distributed computing, energy operations, wireless mesh networks, wireless sensor networks, hybrid wireless networks. First is my military applications, and ad hoc wireless networks can be very useful in establishing communication among a group of soldiers for tactical operations. Setting up of a fixed infrastructure for communication among a group of soldiers in enemy territories or in inhospitable terrains may not be possible. In such a case, ad hoc wireless networks provide required communication mechanism quickly. The primary nature of the communication required in a military environment enforces certain important requirements on ad hoc wireless networks, namely reliability, efficiency, secure communication, and support for multicast routing. Next is collaborative and distributed computing. Ad hoc wireless network helps in collaborative computing by establishing temporary communication infrastructure for quick communication with minimal configuration among a group of people in a conference. In distributed file sharing application, reliability is a high importance which would be provided by ad hoc network. Other applications such as streaming of multimedia objects among participating nodes in ad hoc wireless networks require support for soft real-time communication. Devices used for such applications could typically be laptops with add-on wireless interface cards, enhanced personal digital assistants, or mobile devices with high processing power. And coming to emergency operations, ad hoc wireless networks are very useful in emergency operations such as search and rescue, crowd control, and commando operations. The major factors that favor ad hoc wireless networks for such tasks are self-configuration of the system with minimal overhead, independent of fixed or centralized infrastructure, the freedom and flexibility of mobility, and unavailability of conventional communication infrastructure in environments where the conventional infrastructure-based communication facilities are destroyed due to a war or due to natural calamities. Immediate deployment of ad hoc wireless networks would be a good solution for coordinating rescue activities. They require minimum initial network configuration with very little or no delay. Next is wireless mesh network. Wireless mesh networks or ad hoc wireless network that are formed to provide an alternate communication infrastructure for mobile or fixed nodes or users. Without the spectrum reuse constraint or requirement of network planning of cellular network. It provides many alternate paths for a data transfer session between a source and destination, resulting in quick configuration of the path when the existing path fails due to node failure. Since the infrastructure built is in the form of small radio relaying devices, the investment required in wireless mesh networks is much less than what is required for a cellular network counterpart. The possible deployment scenarios of wireless mesh networks include residential zones, highways, business zones, important civilian regions, and university campuses. Wireless mesh networks should be capable of self-organization and maintenance. It operates at license-free ISM band around 2.4 GHz and 5 GHz. It is scaled well to provide support to large number of points. Major advantage is the support for a high data rate, quick and low cost of deployment, enhanced services, high scalability, easy extendability, high availability, and low cost per bit. And coming to the wireless sensor networks, which are a special category of ad hoc wireless network that are used to provide a wireless communication infrastructure among the sensors deployed in a specific application domain. Sensor nodes are tiny devices that are capable that have capability of sensing physical parameters, processing the data gathered, and communication to the monitoring system. Mobility of nodes is not mandatory requirement in sensor networks. For example, the nodes used for periodic monitoring of soil properties are not required to be mobile, and the nodes that are fitted on the bodies of patients in a past surgery ward of a hospital are designed to support limited or partial mobility. In general, sensor networks need not in all cases to be designed to support mobility of sensor nodes. Size of the network. The number of nodes in sensor network can be much larger than that in a typical ad hoc wireless network. Density of deployment, that is density of nodes in a sensor network, varies with the domain of application. For example, military applications require high availability of the network, making redundancy a high priority. Then coming to the power constraints in sensor network are much more stringent than those in ad hoc wireless networks. This is mainly because the sensor nodes are expected to operate in harsh environmental or geographical considerations with minimum or no human supervision and maintenance. In certain cases, the recharging of the energy source is impossible. Running such a network with nodes powered by a battery source with limited energy demands very efficient protocol at network, data link, and physical layer. The power sources used in sensor networks can be classified into the following three categories. The replenishable power source. The power source can be replaced when the existing source is fully drained. Non-replenishable power source. The power source cannot be replenished once the network has been deployed. The replacement of sensor node is the only solution. Regenerative power source. Hence, here power source employed in sensor network have the capability of regenerating power from the physical parameter under the measurement. Data or information fusion. Data fusion refers to the aggregation of multiple packets into one before relaying it. Data fusion mainly aims at reducing the bandwidth consumed by redundant headers of the packets and reducing the media access delay involved in transmitting multiple packets. Information fusion aims at processing the sensed data at the intermediate nodes and relaying the outcome to the monitor node. Then traffic distribution. The communication traffic pattern varies with the domain of application in sensor networks. For example, the environmental sensing application generates short periodic packets indicating the status of the environmental parameter under observation to a central monitoring station. This kind of traffic requires low bandwidth. Ad hoc wireless networks generally carry user traffic such as digitized and packetized voice stream or data traffic, which demands higher bandwidth. Hybrid wireless networks. One of the major application area of ad hoc wireless network is in the hybrid wireless architecture, such as multi-hop cellular network and integrated cellular ad hoc relay. The primary concept behind cellular network is geographical channel reuse. Several techniques like cell sectoring, cell resizing, and multi-tier cells increase the capacity of cellular networks. MCNs combine the reliability and support of fixed base station of cellular network and with flexibility and multi-hop relaying ad hoc wireless networks. Major advantages are higher capacity than cellular networks due to the better channel reuse, increased flexibility and reliability in routing. Better coverage and connectivity in holes of the cell can be provided by means of multiple hops through intermediate nodes in a cell. That's all about the examples. That is, these are some commercial applications of ad hoc network. Thank you.